Good day, welcome to my channel. Now we'll be dealing with STEM subjects, that is science, technology, engineering, and mathematics. We make it easy, fun, interesting, and quick to assimilate to help in our assignments, homework, and learning generally. Today we'll deal with trigonometric identities. Under this, we'll handle compound angles, double multiple angles, half angles, product of trigonometric ratios, sum and difference of trigonometric ratios, relationship of the trigonometric ratios. Another relationship we have like a sine theta plus or minus b cos theta will give us r sine theta plus or minus beta, bracket open close, and the same, which is equal to r cos brackets closed theta minus plus or plus beta, bracket closed. I am Dimeji. Let us begin. Compound angles. Here is when we know sine theta, cos theta, so that we can find sine theta plus theta or cos theta plus beta. Let's start with a right angle triangle formed by hypotenuse r after it has suspended an angle of alpha. So this place will be r sine alpha, and the adjacent will be r cos alpha. Now, if r now subtends a greater angle and is increased by beta, our new triangle will be formed by rotating the triangle through beta, and that is achieved by anti-clockwise rotation of triangle ABC. So we have something like this. This is beta, and this one comes like this. So A, B, C. I have alpha here. So R sine alpha, R cos alpha. Now, this whole angle is 90 minus alpha. The distance here, let me call this place D, will be R sine BD is equal to R sine alpha plus beta. But let me now make this place E and this place F. I have a rectangle because this place is right angle triangle. This place right angle, this place right angle. So this place right angle. So I have it like this. If this place is 90 minus alpha fully, this place will be 90 minus alpha plus beta. 90 minus alpha plus beta. This place. Now to find this angle here, angle EBC rather. So angle EBC will be equal to 90 minus alpha minus 90 minus alpha plus beta. E is equal to 90 minus alpha minus 90 plus alpha plus beta. So this one will cancel this. So the angle here is beta. That's in the angle by which the triangle is rotated. Now, BD will be equal to BE plus ED. BE from this triangle here is R sine alpha cos beta. To find ED, I realize that ED is the same thing as CF. And from the triangle ACF, CF is equal to R cos alpha sine beta. And this is BE. So CF is equal to ED. So BE plus CF. Therefore, R sine alpha plus beta will be equal to R sine alpha cos beta plus R cos alpha sine beta. So dividing through by R, I have sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. Thank you. Now to find the cosine side, I will go to the adjacents. So R cos alpha plus beta is equal to AD. And that is equal to AF minus DF. What is AF? AF is R cos alpha cos beta. This is the whole from here to here. AF is R cos alpha cos beta. And what is DF? DF is equal to EC. And DF will be equal to, this place is R sine alpha. So it's R sine alpha sine beta, this place. It's R sine alpha sine beta. The most important thing is getting the triangle and the angle beta, what should be there. So dividing 2 by R, I realize that cos alpha plus beta will be equal to cos alpha cos beta minus sine alpha sine beta. Now, for tangents, we know that tan alpha plus beta will be equal to sine alpha plus beta over cos alpha plus beta. So, sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta over cos alpha cos beta minus sine alpha sine beta. Let's divide the denominator and then numerator by cos alpha cos beta all through. So that will give us tan alpha plus tan beta over 1 minus tan alpha tan beta. Now to get the identity for difference of angles, let's start again with our right angle triangle R sine, this is alpha A B C. So R sine alpha R cos alpha. Now let's reduce this angle by beta. We rotate clockwise. So it's going to give us something like this. This place is alpha minus beta. This place is beta. This place is alpha minus beta. And that is, this is R sine alpha. This is R cos alpha. And I have this. I have this. So A, B, C. So I have D, E, F. As before, this place we realize right angle, right angle, right angle, right angle. So this place will be equal to this place. This place will be equal to this place. We are forming rectangle, parallelogram, rectangle. You can see from the angles of all the sides. Now, let's look at R sine alpha minus B minus beta. that is equal to BE. And if you look at it, BE is equal to BF minus EF. BE is equal to BF minus EF. And from this parallelogram, you realize that EF is equal to DC, which gives us BF minus DC, since BF is equal to DC. No, this. Then, what is BF? Before we go on, let's find the angle here. This place was 90 minus alpha. And this place here is equal to the angle here as well. From this sum of all the angles, we realize that this angle here is going to give us 90 minus alpha minus beta. So this angle here will be equal to this one minus this one. So this angle here is going to give us 90 minus alpha minus beta minus 90 minus alpha. So on expanding this, it's going to give us 90 minus alpha plus beta minus 90 minus alpha. So this cancels this. So we are going to have beta. So the angle here is going to be beta. Now, we have found all the necessary things. So, BF now is going to be R sine alpha sine beta. So, R sine alpha minus beta, which is B, is equal to BF, which is R sine alpha cos beta minus, let's see, what is DC? R cos alpha sine beta. R cos alpha sine beta, this side. So dividing through by R, I can say that R sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. Now for cosine, cos R cos alpha minus beta is equal to AE. And AE is equal to AD plus DE. But DE is equal to CF. So, what is AD? AD is R cos alpha cos beta. So, AD is R cos alpha cos beta. What is CF? CF is R sine alpha sine beta. Dividing through by R, I can see that cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. Now, to find the tangents of the difference of two angles, I'm going to divide the sine by the cosine. Tan alpha minus beta is equal to sine alpha minus beta over cos alpha minus beta, which equals sine alpha cos beta minus cos alpha sine beta over cos alpha cos beta plus sine alpha sine beta. Dividing denominator and the numerator by cos alpha cos beta is going to give me tan alpha minus tan beta over 1 plus tan alpha tan beta. Very easy to memorize. If it is for sum of angles, sine will be sine for sum of angles will be sine of the first angle cosine of the second angle plus cosine of the first angle sine of the second angle. If it is difference, this place will be minus. For cosine, it will be cosine of the first angle cosine of the second angle. If it is plus, minus sine of the first angle sine of the second angle. If it is difference, this place will be addition, because as the angle increases, cosine reduces. For tangents, if it is sum, we are going to add the two tangents, and then we subtract the product of the two tangents from 1. If it is subtraction, we are going to have minus at the top, plus at the denominator. Thank you. In double angles, we have it like sin 2 theta, cos 2 theta, tan 2 theta. What happens here is, instead of having alpha plus beta, like this, sin alpha plus beta, they are going to have it to be beta will be equal to alpha. Therefore, we are going to have sin 2 alpha, or cos 2 alpha, or tan 2 alpha, as the case may be. So now to find sin 2 alpha, it's going to be sin alpha plus alpha, sin 2 alpha, which is going to give us sin alpha cos alpha plus cos alpha sin alpha, which is going to give us 2 sin alpha cos alpha. Straight. If it is cosine, we know the relationship for cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. So for cos 2 alpha, it will be cos alpha plus alpha, which will give me cos alpha minus sin alpha sin alpha, which is cos square alpha minus sin square alpha. Now for tan 2 alpha is going to give me tan alpha plus tan alpha over 1 minus tan alpha times tan alpha, which will be 2 tan alpha over 1 minus tan square alpha. So it's very straightforward, very easy to memorize. For sin 2 alpha, it is 2 SC, 2 sin alpha cos alpha. For cos 2 alpha, it is c square minus s square. For tan 2 alpha, it is 2 tan alpha over 1 minus tan square alpha t square. So straightforward, 2t over 1 minus t square. Now, multiple angles. We can say when we are having it like sin 2 alpha, sin 3 alpha, sin 4 alpha, cos 4 alpha, and co. So now, just to show how we can get multiple angles, let's just give an example of like sin 3 alpha. That will give sin 2 alpha plus alpha. And we know what that will be. It's going to be equal to sin 2 alpha cos alpha plus cos 2 alpha sin alpha. And what is cos 2 and sin 2 alpha? That is 2 sin alpha cos alpha. Yes, times cos alpha. And what is cos 2 alpha? That is cos square alpha minus sin square alpha sin alpha. On expansion, I'm going to have 2 sin alpha cos square alpha plus cos square alpha sin alpha minus sin cube alpha. Now, working everything out, this one and this one, they look the same. So I'm going to have 3 sin alpha cos square alpha minus sin cube alpha. I can still factorize or expand this one to have some kind of similarity with this. So you can work as many multiples of angles as possible. You can work out cos 3 alpha, cos 4 alpha, tan 3 alpha, sin 4 alpha. So this is just to show you how to find multiple angles, trigonometric ratios. Half angles. Just as you are able to find double trigonometric ratio of the double angles, you can also find trigonometric ratios of the half angles. Let's start with sine. We know that if we have sine 2 theta, we are going to have 2 cos theta sin theta. Therefore, sin theta will be equal to 2 sin theta over 2 cos theta over 2. Now, let's divide through by what is 1, and we know that 1 is going to be sin square theta over 2 plus sin square cos square theta over 2. We can find our sin 2 theta cos 2 theta straight from here. Let me finish this process. So sin theta, once I know a figure for it, I'm just going to make it like this. 2 sin theta over 2 cos theta over 2 over sin square theta over 2 plus cos square theta over 2. So let me divide the numerator and denominator by cos square theta over 2. So I'm going to have 2 tan theta over 2 over 1 plus tan square theta over 2. So I can get my tan theta over 2 here. Then by other trigonometric ratio identities, I can get sin theta over 2 and cos theta over 2. After solving this using some quadratic method, I can also get it straight from here. I can say sin theta is equal to 2 sin theta over 2 square root 1 minus sin square theta over 2. And using knowledge of sort and quadratic equation, I can get sin 2 theta here. In the same vein, I can get cos 2 theta from here. Very easy. Now if I have cos theta, it will be equal to cos square theta over 2 minus sin square theta over 2. And this will give me cos square theta over 2 minus 1 plus cos square theta over 2, which will give me 2 cos square theta over 2 minus 1. And it can also be 1 minus 2 sin square theta over 2. So from here, if I have cos, I can easily find cos theta over 2 sin theta over 2 by solving this algebraically. Cos theta plus 1 over 2 will give me cos square theta over 2. So I find the square root. For this one, I just subtract cos theta from 1 and I divide by 2. It gives me sin square theta over 2. And then I square root. Now, I can also get tan theta over 2 straight from here. So I make it like this. Cos theta is equal to cos square theta over 2 minus sin square theta over 2 over cos square theta over 2 plus sin square theta over 2. So dividing denominator and numerator by cos square theta over 2, I'm going to have 1 minus tan square theta over 2 over 1 plus tan square theta over 2. And solving using simultaneous quadratic equation, I can get tan theta over 2 straight from there, and cos theta over 2 sin theta over 2 later on. I can also bring in, if I am given sin theta, I can bring it into this formula here. I can say cos theta equals to root of 1 minus sin square theta, which should give me, I think I've done that one. 1 minus 2 sin square theta. 2, okay, sin square theta over 2 cos square theta over 2 minus 1. Now, if we have tan theta, we know that tan theta is equal to 2 tan theta over 2 over 1 minus tan square theta over 2. I have a unique way of memorizing this. I draw a triangle like this. I make this 1 plus tan square theta. This place will be 2 tan theta, and this place will be 1 minus tan square theta. Yeah, make it over 2 over 2 over 2, and this place will be theta. So if you have sin theta, it's going to be, okay, let's say cos theta. 1 minus tan square theta over 2 over 1 plus tan square theta. That's cos theta. Sin theta, 2 tan theta over 2 over 1 plus tan square theta over 2. And tan theta, 2 tan theta over 2 over 1 minus tan square theta over 2. Thank you. Now we are treating products of trigonometric ratios. We have sin alpha cos beta plus cos alpha sin beta equals to sin alpha cos beta. Sin alpha cos beta minus cos alpha sin beta equals to sin alpha minus beta. That's equation 2. Cos alpha cos beta minus sin alpha sin beta equals cos alpha cos beta. Equation 3. Cos alpha cos beta plus sin alpha sin beta equals to cos alpha minus beta. That's equation 4. Now let's add equation 1 and 2. 1 plus 2. So what does that give me? It gives me 2 cos alpha, 2 sin alpha cos beta is equal to sin alpha plus beta plus sin alpha minus beta. So what does that give me? What does that mean? When you have product of sine of an angle with cosine of another angle, it's going to give you the sine of the sum of the angles plus sine of the difference of the angles divided by 2, because these two must be considered. Now let's subtract equation 2 from 1. So I have 1 minus 2. That gives me 2 cos alpha sin beta will be equal to sin alpha plus beta minus sin alpha minus beta. Now let's add equation 3 and 4. So it's going to give me 2 cos alpha cos beta, and that's going to give me cos alpha plus beta plus cos alpha minus beta. Let's subtract equation 4 from 3. So that will give me minus 2 sin alpha sin beta, which means I'm going to have cos alpha plus beta minus cos alpha minus beta. So you can see, when we have the same trigonometric ratios, is either sum of cos or difference of cos. When we have cos mixed with sine, it's only sine. Sum of sine, difference of the sine. Thank you. Now we are treating sum of trigonometric ratios. Sin alpha plus beta equals to sin alpha cos beta plus cos alpha sin beta. Sin alpha minus beta equals to sin alpha cos beta minus cos alpha sin beta. That's equation 2. Cos alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta. Equation 3. Cos alpha minus beta equals to cos alpha cos beta plus sin alpha sin beta. That's equation 4. Now, we are trying to have a situation like when we have sin A plus sin B or sin cos A plus cos B, what will it result to? So let's make it like this. Alpha plus beta is equal to A. We are going to use our knowledge of simultaneous equation. Alpha minus beta is equal to B. So alpha is equal to A minus B. So alpha is equal to A minus B over 2. Same way, beta. Oh, sorry. So alpha is A plus B. So alpha is A plus B over 2. Beta is equal to A minus B over 2. Now, since this one is established, alpha is A plus B over 2. Beta is A minus B over 2. Sin alpha plus beta minus sin alpha minus beta. Sin alpha plus beta. Let me add the 2. 1 and 2. Plus sin alpha minus beta. When I add the 2, it's going to give me 2 sin alpha cos beta. From here, you can see that this one is sin A plus sin B. We are trying to express this equation in terms of A and B only. So, alpha is A over B, A plus B over 2. So, we have 2 sin A plus B over 2. And we cos A minus B over 2. So which means that if I have sin A, sin B, it's going to give me 2 sin A plus B over 2 cos A minus B over 2. And if I have sin 45 plus sin 60, it's going to give me 2 sin 105 over 2 cos 15 over 2. Now let's go to another one. Let's subtract equation 2 from 1. So I'm going to have sin alpha plus beta minus sin alpha minus beta. It will give me 2 cos alpha sin beta. So we have sin A minus sin B is equal to 2 cos A plus B over 2 sin A minus B over 2. So if I have sin 60 minus sin 45, it's going to give me 2 cos 105 over 2 sin 15 over 2. Now let me add equation 3 and 4. So I'm going to have cos alpha plus beta minus cos alpha minus beta. It's going to give me, if I add the 2 cos alpha cos beta. So let me express everything in terms of A. This time around it's going to be cos A plus cos minus. This one should be plus. Cos alpha plus beta plus cos alpha minus beta. This one we cancel out. So I'm going to have 2 cos alpha cos beta. So I have cos A plus cos B is equal to 2 cos A plus B over 2 cos A minus B over 2. Now, let me subtract equation 4 from 3. So I'm going to have cos alpha plus beta minus cos alpha minus beta is equal to minus 2 sin alpha sin beta. So this will give me cos A minus cos B is equal to minus 2 sin A plus B over 2 sin A minus B over 2. Here we are talking about trigonometric ratios, relationship identities. Just as a reminder, we have a triangle like this. This place is hypotenuse, theta, opposites, adjacent. And from Pythagoras theorem, you know that hypotenuse square is equal to opposite square plus adjacent square. Now, let's divide through by hypotenuse. This will be 1 opposite over hypotenuse square plus adjacent over hypotenuse square. So 1 will be equal to sine square theta plus cos square theta. Let's divide through by cos square theta. So I'm going to have sec square theta is equal to tan square theta plus 1. Since 1 over cos theta is equal to sec theta, 1 over sin theta is equal to cosec theta, and 1 over tan theta is equal to cot theta. Now we can still go further by going to the first equation and divide through by sine square theta. So I'm going to have cosec square theta is equal to 1 plus cot square theta. So you can derive as many equations as possible. You can even multiply this one by cot theta anyhow. So what I'm trying to say is this: any relationship, any identity given to you or asked for, you can easily derive them by using this basic equation and substituting into any other equation. Thank you. Now we have a relationship like this: a sin theta plus or minus b cos theta equals to r sin theta plus minus alpha. So let's start. I have it like this: a sin theta plus or minus b cos theta is equal to r sin theta cos alpha plus or minus r cos theta sin alpha. If you compare the two equations, you will see that a here is equal to r cos alpha, b here equals to r sin alpha. So b, now a equals to r cos alpha, b equals to r sin alpha. So b over a equals to tan alpha. That is r sin alpha over r cos alpha tan alpha. So alpha is equal to r tan b over a. Now I have a equals to r cos alpha, b equals to r sin alpha. So a square plus b square is equal to r square cos square alpha plus r square sin square alpha, which is equal to r square into cos square alpha plus sin square alpha. And cos square alpha plus sin square alpha is equal to 1. So a square plus b square is equal to r square. So the above equation, that is a sin theta plus or minus b cos theta, a square plus b square, since this is r, sin theta plus or minus r tan b over a. Now let's go to a situation where this will be r cos theta plus or minus alpha. So this will be a sine theta plus or minus b cos theta to be equal to r cos square alpha. No, cos theta cos alpha plus or minus r sine theta sine alpha. On comparing this now, we can see that A will be r sine alpha. B is r cos alpha. So A over B is equal to r sine alpha over r cos alpha, which is tan alpha. So alpha is r tan A over B. Then A squared plus B squared is equal to r squared sine square alpha plus r squared cos square alpha, which is r squared into sine square alpha plus over